Okay, we're asked to find the rate at which the distance between a plane that is flying horizontally directly above a radio tower is increasing 1 minute after it flies overhead. Now, to solve this question, we're going to use the method of implicit differentiation, which is just a fancy way of doing the chain rule. So first of all, when I get a question like this, I like to draw it out. Now, the distance that the plane is away from the radio tower can be gathered using Pythagoras. And to start with, we're going to need a triangle. Here's one I prepared earlier. So we've got a 5 kilometer altitude that the plane is flying at, which is this side of the triangle. I've called the distance that the plane is away from the radio tower S. And I've called the horizontal distance that the plane is from its original position, which is directly above the radio tower X. So we can start off by creating a formula which defines our S in terms of X. So we have S squared would equal 25, which is 5 squared, plus X squared. Cool. And we've got this X term. Now, X is going to be a function of time. And we know that the plane is going 600 kilometers an hour. So the distance that X is going to be 600 times by the time, where time is in hours. Okay, so to find, this is where our implicit differentiation comes in. To find our change in S, we're going to differentiate this formula here. Now we start by differentiating both sides with respect to time, because that's what we've got to end up with. So we're going to go d S squared dt is equal to d25 dt plus dx squared dt. Now it's pretty obvious that this middle term, if we're going to try and find a rate of change of a constant number with respect to anything, that's just going to be equal to 0. Now this term here, the way we're going to be able to find out what dx squared is in terms of time, this is where we employ the chain rule. We're going to have, this is going to equal dx squared dx times dx dt. So this is just the chain rule here, and these two rates of change multiplied together will give us the above rate of change. And for this one here, we're going to do exactly the same thing. We're going to have d of s squared ds times ds over dt. Cool. So now that we've got those relationships, we can put them back into our formulas and compute a few of them. So we'll start with computing the rate of change of s squared with respect to s. Now, that is just going to be 2s, because the derivative of s squared is just 2 times s. And we're multiplying that by ds dt. And that's going to be equal to, we don't need the 0 anymore, the derivative of x squared with respect to x is 2x, and then that's multiplied by dx dt. Now, we're looking for the rate of change in s with respect to t, which is this. So here we have the rate of change that we're trying to isolate. So what we're going to do is we're going to take our s's over the other side, which is going to give us two x over 2s times dx dt, which we know that these 2's can be cancelled out to simplify. So as a result, we can say that ds dt, the relationship between these, is x divided by s x divided by s times dx dt. Cool. So we know that dx dt, well, x in terms of t is 600t. So we can say that dx dt is just going to equal 600. Cool. So finally, I'll just give myself some room. I'll move over here. We're looking for ds dt when t is after 1 minute. So as t is in hours, t is going to be 1 over 60 is going to equal x after 1 minute. So if it goes 600 kilometers in an hour, it's going to go 10 kilometers in a minute. And s is going to be the square root of 125. And then we're timesing that by dx dt, which we know is 600. And then that can be simplified. We know 125, if you're going to simplify that third, is going to be 5 square root 5 times 600. So this finally is going to be equal to 10 over 5 is the same as 2. 2 over root 5 times 600 is 1200 divided by square root 5, which is approximately 537 kilometers per hour. So that's the method of using implicit differentiation to solve a situation which is in terms of two changing variables. I hope it's helped, and talk to you soon.